Hi everyone, I'm Aaron Rump, and today we're going to be going over a video on how to set up a Vericut project to check a turning program on a model. So I'm going to be looking at this part right here. I'm going to be taking a program that I think is good, and I'm going to be setting up my Vericut with the machine, the control files. I'm going to build some stock material. I'm going to bring in a model, and then I'm going to set my work offsets, create a CSIS, and then I'm also going to bring in my program and my tools, and we're going to kind of go from there. Now we are going to run into some hiccups in this video, but I'm going to show you how to troubleshoot these errors so that you can work on your projects and become successful in setting it up. So let's get started. So when I open up my software, I'm going to come up here to Start. We're going to do a new project, and then when I go to save my project, it will allow me to rename it. So you see up here it says unnamed. Sometimes it will pop up a little window asking you if you'd like to change the name. So the good news is this project is not going to take us very long. So let's get going. So on control, I'm going to come over here and I'm going to go to either right click and open, or I can double click on it. And you'll see me going to my desktop and coming down to my Vericut file, where I've saved all my project information. So I'm looking for a control file. I'll open that up and I'll use my lathe that I've made. I'll also come up to my machine and I'll do the same thing. I'll double click on it. I'll go to my desktop, come down to my Vericut, and I'm going to go to my machine files because they are different, and then you'll see that it does populate right there. So that's the easy part right there, just getting those under control. Now you can find a variety of control and machine files. If you look right here, on ours it's through CG Tech, Vericut, and the library, so you can follow this pathway if you need to get where it is. So we'll go ahead and minimize that for right now. And the next thing we're going to do is we're going to start building our stock. So the project we're going to be doing is going to be this right here. So I already have a program made for this. The only thing I'm really going to grab from here is the stock length and the stock diameter, and we'll go from there. So I'm going to come down to stock, and the one thing I want to make sure is when I come down, I want it to be visible in both views. Now you can have it be invisible or in one of the other views. I always have both views, which is what it usually defaults to. I'm going to simply make a cylinder, and I know my dimensions. My dimensions were 1 inch, 875 thousandths, and you can't see it, so let's go ahead and scroll up on it. And then if I look right here, I have a radius. So the radius is going to be obviously half the diameter. So my diameter is 1 inch, 250 thousandths, but I can simply type in a divided sign, the number 2, and hit enter, and you'll see that it does populate the correct radius for me. So left clicking will rotate my stock, right click will move it around, and then if I click and hold the middle mouse, I can make a zoom to fit window, or I can scroll up and kind of find it wherever I want it to be. So you'll have to get kind of used to that. But the next thing I want to do is I need to come up and click anywhere in the window. When I bring in my model or my design, I want to be able to see it inside the material. So I'm going to right click on my stock. I'm going to come down here to where it says appearance, and I'm going to change this to about half translucent, and I hit enter, and then I'll simply hit exit. And then I click back off of it, and you can see that it does not turn solid anymore. The next thing I'm going to do is bring in my design. Again, I want to make sure it's going to be visible in both views. So by default, it goes to invisible. I like to click both views, and then I'm going to come down here to add model. I'm going to go to a model file, and then again I'm going to go into my desktop. I'm going to come into my Vericut file, and I'm going to go into my exercise. Now, it's always good to have a folder with all of your information in it. So for example, if I hit my drop-down menu and I go to all files, you're going to see I have a number of items in here. Okay, so, but honestly, I want it to be showing just my files for that. So I'm going to hit combine all files that are compatible with bringing in a model. Now, if you'll notice, I have a SolidWorks part, but when I bring that in, sometimes it doesn't work very well, either due to the size or the licensing issues. So when I saved my SolidWorks part, I saved it as a parasolid, which is a X_T. That's what I like to bring in. Plus the file is much smaller. That's why I'm bringing in this instead of the part. I will click OK. It's going to bring it in as best it can. We will have to do a little bit of moving. So when I get to this part, I'm going to rotate. I'm going to click around Z and see if that works. Well, that's not working. So I'll put it back to where I found it. And I'll try the Y. So the Y looks like it's going the right amount. It's going 30-degree increments. And one more time puts me at 90 degrees. So that looks good. You'll have to play with that to where you have it to where you like it. The next thing I want to do is I want to move it into my material. Now this is why I leave my material the full length when I create it, because it makes this part a little bit easier. So I'm going to put it at 1 inch, 875 thousandths. I'm going to hit enter. When I hit enter, you'll see that it is flush with the front and back of the material. So that's why I do that. So I'm going to put it back into my isometric view. And now that I have this all set up, it's time to go ahead and set my work coordinates. So I'm going to close this. I'm going to go into my coordinate system. I'm going to add a new coordinate system. Now by default, it's going to bring it to the back. It's pretty much our base location of our material. That's where the material grows from. So I'm going to leave it there. And then I'm going to go into positioning of that work offset. So I'm going to move it the same amount as I did the front of my part. And I'm going to hit enter. So you'll see that it translates it from the base up. Now when I built my model, I could have easily had my material go in the negative direction for Z. And then whenever I hit the add new CSYS, it would have put it right here at the face of it. This is just how I'm showing it in this example. So I now have a coordinate system. Now I have to tell my G code offset, which is in my program, where it's located at. So under System ID, it's under 1. I'm going to change this to base work offset because it's coming off the location of where the CSYS was first established. I'm going to go to CSYS number 1 and I'll simply click add. So now that I have that there, it's going to work out really good. Now if I have multiple work offsets to help clear up the confusion on my ladder, I can right click and go to rename. I can change that to G54 and hit enter. And you'll notice that it does change here correctly. The next thing I'm going to do is I'm going to go to my tooling. Now if you have a tooling file to bring in, that's great. So what I'm going to do is I'm going to bring in the one that I have created for this example by double clicking. I'm going to go to open file. Let's go to that Vericut folder, exercise number 3, and I got my exercise tools right here. I'm going to hit open. Now this tool list was a generic tool list, so if you are looking for more tools, you can always come right here and you'll see that inside the training folder there is a list of lots of tools that you can go through. However, I've taken a sample tool library and I have made some small adjustments. The biggest thing I'm going to have to adjust when I'm changing something is if my program calls for tool 5, the name of my tool needs to be 5, and I need my driven point to be number 5. So if you bring in a tool library, one of the things you'll have to make sure is that your tool library matches your program. So I'm going to be using tool number 2, and you see I have that identified. Number 5, which is my groover, and the 6 for my threading tool. So now that I open that up, we'll come back to this here in a little bit. I'm going to hit exit, and you'll see that it does save that there. So I don't have any assemblies. I'm going to go straight to my program. So down here, I'm going to click Add NC Program File. We'll go down to the Vericut file, and we'll go to that exercise. And you'll see I have this exercise. This is the program that I've already written. We're just going to check to see if there's anything that's going to gouge into my material or if there's going to be any crashes. So I'll hit OK. Now everything is set up. And this is really cool because now I can move my part out of the way. I usually like to click on this little line, so not left, not top, but the actual line. It kind of centers it up a little bit better. Now, I always take my animation speed and I drop it all the way down. But at this point in time, I want to hit play and see what happens. So my tool will come into view. I'll zoom out just a little bit so we can see it. Now, if you'll notice, I have some alarms coming on up here. We'll look at those here in just a second. And then I'll have my grooving tool will come in. And then I'll have my threading tool will come in. And then once it's done threading, this program is designed to come over with the grooving tool, put the chamfer on the back, and part it off. So good. So my program is done. I do have some alarms here though. Now we're going to kind of address these from here in just a second. But the first thing I want to do before I do anything else is I want to see if my program is violating the model. So I'm going to come up here to Analyze. I'm going to go up to Compare. And if I look here, I can see I've got a lot of gouging going on. Well, let's make sure I have this set up right before I do anything else. I'm going to hit Auto Defer. And I'm going to make sure that my compare is set up. Well, it shows me my gouge range is 4 thousandths and my excess material is 4 thousandths. So if I just hit apply and compare, I'm going to get the same result here. So I've got some extra material going on right here at the back of my threads. And I have all this over here. Now, something I like to do on my models is I do not put the threads on the model, because where the thread enters the part on the simulation versus where the thread enters the part on the program, it sometimes does not line up and it kind of makes it look a little funky. So we're going to go ahead and hit exit on here. We're going to hit eject. We're going to reset the simulation. And we're going to try to find out what was going on right there. So I'm going to look at my program, and you'll see that I do have cutter comp turning on as it's coming to the clearance point, and my code looks pretty good. So I'm going to have to find out what's going on because it's not my program at this time. So I'm going to exit that out. So what's happening is my tool nose of the tool is not being incorporated. So I'm going to come up here to Setup. I'm going to come down here to G-code, and I'm going to click on the cutter comp process, and I'm going to put it to on so that it defaults to the full radius of the tool from the tooling library. That's a lot just to say, hey, don't forget my tool has a radius. So I'm going to hit eject. I'm not going to touch anything else. I'll hit OK. I'll come back to my simulation. I like to zoom up. Obviously, that was where my tool starts at. And I'm going to hit play one more time. Now, this time when it comes in, you might be able to see a little bit different how it's not cutting into my material. And it gave me a new error right here that I'm going to have to address. Now, it's still left a little bit right here, and we'll look at that as well. But I want to see if that cutter radius compensation being on helps fix some of my issue going on. So we're just troubleshooting. So you can see my threads are in there. They do look good. I'm going to come back up to compare. And you'll see this looks a lot better on the turning. So my turning, you can see it's translucent. That means everything's looking pretty good. But I still have a solid blue right here, and I'm undercutting right here. And again, you can see where my threads, I usually have my model set to have no threads, or else I would have blue and red, and it just really clutters up this image right here. So I have to look at this and see what's going on. So I'm going to hit eject, and the next thing I have to look at is my tools. So I know my cutter comp fixed my tool number 2. We're going to look at the tool that does my grooving. So we'll come up to my tools, and I'm going to go to my grooving tool, and again, I can zoom up on here, or I can make a little window to zoom up on that. So if you'll notice, this location right here needs to be where the radius tip would be. So if there was no radius, it would need to come out to this corner. So I'm going to open up the tool of the cutter, and you'll notice it says it's on the center. Sometimes it'll come up with the no location. But what I want to do is I want to put it on the bottom left here. So it will refresh. I'm going to zoom back up on it. And you'll see that it puts it down here. So now it's going to realize that there is a radius, and it should offset correctly. Also, the back side of the tool was not cutting, so it was offsetting too much. So I'm going to minimize this, I'm going to exit. It's going to ask me if I want to save. If I hit no, I'll get the same result. I'm going to hit yes, and I'm simply going to hit play again. This time, obviously, my turning tool is fixed, but let's see what it does with my grooving tool when it comes up. So my grooving tool is going to come up, and you'll see that it did fix this right here. And when it gets done threading, we'll watch my grooving tool come back here to the back side, and then we'll go up to here to compare. So I'll hit compare, and you'll see that it did fix it. Now again, this blue right here has a little bit to do with my tool nose radius. Now if you can get it to be a 0 tool nose radius, it will help. But that's what I'm looking at right here, is some of that tool nose that's interfering with my model, because my model shows a square corner and my tool has a 0 on it. Now what I've been running into is when I try to change it to a 0 on my tool list right here, which should be pretty simple. I come up to here and I would just go to the tool nose radius and I change that to a 0. But with this sample library, it tends to mess it up. So if I put a 5 thousandths or even a 1 thousandths on there and I bring this back up, it tends to really want to mess up my tool holder. So just knowing what's happening right here is good, and if you're able to fix it, great. Be sure and let me know. I'm going to hit exit. I'm going to hit no, because I understand what the blue is showing me. And now that I can see that my turning is good, I do have some of the blue here from my tool having a radius on it, and my threads do look like they are in the part, but they are not going on top of the model, so I know my groove depth is correct. The next thing I want to look at is I want to look at some of these errors that I had down here. So I'm going to move this up a little bit, and you can see that I've got some deviations and some collisions. So I'm going to hit eject, and I'm going to run it one more time so we can kind of see it a little bit better. And you can see I've got some errors going on here along with that little dig. So we're going to look at both of them real quick. So if we look here, it shows that I have some errors going on. It says a fast feed rate removal, and it's on line 31. So I'm going to open up my program, and if you look down here on line number 1, you'll see that that's at the top of my program. So I'm going to scroll down and just click somewhere, and you'll see that it says I'm on line 27. So I'll cursor down to line 31. So if I'm looking at this, it shows that I'm leaving the material. This is my Q line, but my material is 1 inch 250 thousandths. So I shouldn't have any errors leaving the material by more than 100 thousandths. So let's come back down and look at this error just a little bit closer. You'll notice that it says I'm in rapid mode, but I am in a G71 can cycle when I'm cutting this material. So this machine that I'm using right here is just a generic 2-axis lathe machine that I got from the CG Tech library. So something in its logic doesn't recognize that even though I'm in a G71 can cycle, it thinks that I am in rapid mode while cutting that initial line before it sees this right here. Why it does that, I'm not sure, but watch this. I know my program is good, but I'm going to lie to my machine and change that to a G01, and I'll go ahead and put the feed rate right here, and I'll hit save. And I'm going to hit exit, and all we're going to do is eject, and we're going to hit play one more time. So now it knows that there is no rapid modes. All of a sudden, all of my alarms for that has gone away. Now something I do want to point out is it says that there's a cutter compensation caused by an inverse motion on line 29. Now, line 29 is right before it swings this radius. So what's happening is it's moving across the part diameter, but before it can swing this radius, my tool radius compensation is dipping down so that it can correctly swing that radius. So it's kind of like an illusion. So it's going to do that move, but it's actually not hurting anything because I'm still above the finished groove. So this is what you would call a non-monotonous move inside the can cycle. So I'm going to hit play one more time. And I'll let it go down there. So now we can check to see if I have any more alarms. So my grooving cycle did not have any alarms. My threading cycle did not have any alarms. Now let's see if I have any cutoff alarms. So right there, you can see that I have no more alarms in my program other than that cutter compensation error that was right here at the end. And then I'll go back up to compare. And you can see that the only errors I really have right now that I'm not going to fix at the moment is simply seeing the threads inside the part, because my model does not have threads on them, and my corner radius on my grooving tool is just leaving a little bit of material right there. But if I can ever get that tool nose radius to fix itself without trying to move my origin around, I'll be in good shape. So now here's the good news. I have my part, my model, and my program all developed in here. At this point in time, I would go to File, I would go to Save As or Save All. I'd come in here and I type in Programming Exercise Sample. And then wherever I want to put it at, I would just simply hit Save. I'll hit Cancel because I already have it all done. All right, well, congratulations. We have successfully gone through and created our Vericut project. We've checked our part, we've checked it to the model, we've checked our program. We did a lot of troubleshooting just now, but keep in mind, there may be more things that you run into. You just got to kind of troubleshoot those as you come across them, okay? So again, my name is Aaron Runk. I hope you like this video. Be sure and like and subscribe to this channel so that you can see more videos as they come out. Have a good one.